Let's look at example 3. I've already taken the liberty of rewriting example 3's system of equations as an augmented matrix. We need to get this into row echelon form. So remember, we focus on the zeros first. Now, to get the zeros in the right place, we're going to do the same 3 steps that we did in the first video. So if you remember, the first step we did was we did row 1 and row 2, and we did elimination on the first column. And we replaced row 2 with that answer. So that was the first step that we did in the first video. So you're going to take row 1 and row 2, do elimination on the first column, and replace row 2 with that answer. So I'm going to have you pause the video, try that out on your own. You should hopefully be getting a little bit faster at this. Then come back and check your work. Let's see how you did. I took row 1 and row 2. I did elimination on the first column, and then I replaced row 2 with that answer. Now, notice we can actually skip step 2 from the first video because I already have that 0 in place. Step 1 got me this 0. It already has my second 0. So now I can just work on my third 0 right there. So I'm going to skip to step 3 from our first video, which is where we did row 2 and row 3. And we did elimination on the second column. And we replaced row 3 with that answer. So pause the video, try this one, take row 2 and row 3, do elimination on the second column so that you can replace row 3 with that answer, and then come back and check your work. You should have noticed something very specific. When you did elimination on row 2 and row 3, first off, you didn't need to multiply by anything, it automatically eliminated. But you ended up with a row of zeros, which we did replace row 3 with. So that should tell you immediately this is a consistent dependent system. Because it has a row of zeros, we're going to end up doing that T thing. However, before we do the T thing, we still need to get it into row echelon form. Meaning, I have all my zeros in the right place, but I still need a positive 1 on the diagonals. So we're going to do our next step. Focus on, now that all the zeros are in the right place, now I can focus on the 1s. So I need that to be a positive 1. So I'm going to do row 1 divided by negative 1. And I'm going to start to go a little faster. At the same time, I'm going to do row 2 divided by negative 1. Divide that by a negative 1. So then that way, I can have my positive 1s on the diagonal. So we're going to take row 1 and divide everything in row 1 by a negative 1. So divide everything in here by a negative 1 gives me a positive 1, positive 2, negative 1, positive 1. And then we're also going to divide row 2 by a negative 1. So that gives me positive 1, negative 2, 0. And then I have my row of zeros that tells me it's consistent dependent. Now we can check for row echelon form. Got my upper triangular form. I got 1s on the diagonal. My row of zeros is on the bottom. So this is officially in row echelon form. So now that it's in row echelon form, let's put the letters back in. So I got 1x plus 2y minus 1z equals 1. And I got 0x, 1y, I don't really need that one, minus 2z equals 0, and then my row of zeros. So now that I know that this is consistent dependent, I can start by saying the last letter alphabetically equals T, just like always. Now I'm going to take my second equation. I'm going to replace the Z with that T, substitute it in, and solve for Y. I get y equals 2t. And then I'm going to go with my top equation. Plug in the 2t for y, substitute that in, minus, plug the t in for z, substitute that in, and I get x plus 4t minus t equals 1. 4t minus t is 3t. So I get x equals negative 3t plus 1. Now that I have my consistent dependent answers, I can write them out. Negative 3t plus 1, comma, 2t for y, comma, t for z. And that gives us the infinite set of solutions that work for this system. You can plug any numbers you want in for t, and that's a point that works here. So let's write, just so we remember. Oh, I already have it written. Never mind, we're good. This is consistent dependent. So that is an example of a consistent dependent with row echelon form. In the next video, we'll introduce our last vocab word of the day.